Hello everyone, welcome to my channel Maths Equation. In this video, we are going to discuss construction of a similar triangle from practice set number 4.1. So, let's start. Okay, this is question number 1 from the practice set number 4.1. Now what is there in question number 1? Look at this question. Triangle ABC similar triangle LMN. That means such a type of the similar triangle will be given. In a triangle ABC, AB is equal to 5.5 cm, BC is equal to 6 cm, CA is equal to 4.5 cm. Then construct triangle ABC and a triangle LMN such that now this ratio is given BC upon MN is equal to 5 upon 4. Okay. So in case of this triangle ABC, three sides of this triangle ABC are given, and as these two triangles are similar, that means we have to find out the corresponding sides of another triangle. That means we have to find the three sides of this triangle LMN. So let's find out that three sides of the another triangle. Okay, so whatever is given we will write as it is. So this triangle ABC similar triangle LMN. Okay, now this is given, and we know that if two triangles are similar, then corresponding sides in a proportion, so that we can write here AB upon LM is equal to BC upon MN is equal to AC upon LN. Look at this. Okay, and you can write this reason here. Okay, what is the reason behind it? CSST, corresponding sides of similar triangle. Now if sides are in a proportion, so let's put down the values of this AB, BC and AC. AC, that means CA. Okay, so AB is equal to 5.5 cm upon LM as it is. We have to find out that LM. Now BC is equal to 6 upon MN. Okay, and that AC, which is 4.5 cm upon, which one this one LN. Okay, is equal to, now this ratio is given BC upon MN is equal to 5 upon 4. So write down that 5 upon 4 in front of this one. So let's find out one by one by taking this ratio and this value which is given. 5.5 upon LM is equal to 5 upon 4. So by making cross multiplication, this will be 5 LM is equal to 5.5 into 4. Now transfer this 5 to the RHS. So it will become LM is equal to 5.5 into 4 upon 5. So let's divide this 5.5 by this one. So 5 ones are 5, again 5 ones are 5, 5 ones are 5. So this will be a 1.1. So look at this, 1.1 into 4, that will be LM is equal to 4.4 centimeter. Okay, so let's find out this side MN. So second ratio is 6 upon MN is equal to 5 upon 4. Again by making cross multiplication, that 5 MN is equal to 6 4s are 24. Okay, so MN is equal to 24 upon 5. Okay, this 5 will goes here, so 5 ones are 5, 5 4s are 20. How much remain? 4. So take a 0, so it will become so decimal will be here, so 5 8s are 40. So MN is equal to 4.8 centimeter. Okay, so second side of the triangle LMN is 4.8 centimeter. Now let's find out the third side of the triangle LMN. So let's take that third ratio, which is 4.5 upon ln is equal to 5 upon 4. Okay, so again by making cross multiplication, this 5 ln is equal to 4.5 into 4. So ln is equal to 4.5 into 4 upon 5. Okay, so again 5 ones are 5, 5 nines are 45, but this is not 45, so that answer will be 0.9. So ln is equal to 3.6 centimeter. Okay, this 0.9 into 4, that will be 3.6 centimeter. Okay, in this way we can easily find the three corresponding sides of the second triangle. So let's construct these two triangles, triangle ABC and a triangle LMN. The both triangles. So the first triangle is triangle ABC. Okay, so let's draw that ABC, rough figure of that ABC. Okay, so this is the triangle ABC. Okay, so in this triangle ABC, three sides of the triangle ABC are given, that AB is equal to 5.5 centimeter, BC is equal to 6 centimeter, and CA, that means AC, is equal to 4.5 centimeter. Okay, this triangle is given. So let's draw that another triangle, rough figure of the triangle LMN. Okay, so this is the triangle LMN. Okay, so this is the triangle LMN, in which LM is equal to 4.4 centimeter. We got that 4.4 centimeter, this one. Then MN is equal to 4.8 centimeter, like this. And last side, this is LN, which is 3.6 centimeter. Okay, so these are the rough figures of triangle ABC and triangle LMN. Okay, so let's construct both triangles here. So how much is the BC? BC is the 6 centimeter. Okay, so let's draw that 6 centimeter first. Look at here. Here is a 0. Okay, 6 centimeter up to here. Okay, now this is side BC. Okay, this is BC, which is a 6 centimeter. Now distance between B and A is 5.5 centimeter. So let's take that 5.5 centimeter in a compass. Okay, so we have to take that 5.5 centimeter with the help of scale, and that 5.5 centimeter is like this. Okay, look at this, 5.5 centimeter here. So hold this compass on a point B, like this. Look at it, point B, then make one arc. Okay, now from same point A at a distance 4.5 centimeter from this C. So let's take that 4.5 centimeter. Okay, look at this, 4.5 centimeter, and hold this compass on a point C. Intersect the first arc. Okay, now you can erase this extra arc over here, like this. Okay, now here we got that point of intersection of these two arcs, which is a point A, vertex A of a triangle ABC. And let's join this A with B. Okay, this is the point A, and now point A with a C. Okay, so write down the measures of both segment. 5.5 centimeter and this one is 4.5 centimeter. In this way easily you can construct triangle ABC. Okay, so let's construct triangle LMN. Okay, similarly base of that triangle LM 4.8 centimeter. So MN is there, so let's take that 4.8 centimeter. From this 0, 4.8 centimeter exactly over here. Okay, so this is MN, which is a 4.8 centimeter. Now this point L, vertex L of a triangle LMN at 4.4 centimeter from the point M. So let's take that 4.4 centimeter like this. Okay, 0 is here. So 4.4 centimeter exactly here, and hold this rounder on a point M and make one arc like this. Okay, now same point L at 3.6 centimeter from this N. So let's take that 3.6 centimeter. centimeter like this. Okay, and hold this compass on a point N, intersect the first arc. Now this point of intersection of both arc is L. Okay, so let's join this point with this M and N so that we will get that first triangle. Okay, and this N with a L also. Okay, so this LM is 4.4 centimeter and 3.6 centimeter. In this way easily you can construct both triangle LMN and triangle ABC. How simple is this? Okay, so let's move toward the next question. So this is question number 2 from the practice set number 4.1. Now again two triangles are given which are similar to each other. Triangle PQR similar triangle LTR. But look at the difference between the first question and second one. Now in this question this vertex R is a common in between these two. Okay, now if such a type of the triangles are given in which any one vertex is a common, at that time just like the first one, need not to solve anything here. Okay, so you can directly construct these two triangles, but before that you have to find out which triangle is a smaller and which is a bigger. And how to find out that which triangle is smaller and which is bigger? Now this ratio will help you. Okay, now this PQ upon LT is equal to 3 upon 4. Now look at this, 4 is greater than this 3 and 4 is corresponding with LT, and this LT is a side of this triangle LTR. Okay, that means this triangle LTR is a bigger one and this triangle PQR is a smaller one. Okay, now measures of which triangle is given? Look at this, in a triangle PQR, PQ and this QR and PR, three sides of this triangle are given. That means measures of smaller triangle is given. Now in case of this smaller triangle, when you are going to construct this triangle, okay, so look at this. Suppose this is the rough figure of the triangle PQR. So this is the triangle P, this one is a Q, P, Q and R. So this PQ is equal to 4.2 centimeter like this. QR is equal to 5.4 centimeter and this PR is equal to 4.8 centimeter. Now if measures of a smaller triangle is given, at that time you have to extend this base in the opposite direction of this common vertex like this. Okay, every time you have to extend this base, okay, like this. Not only this base but this side also, that means two sides which making that angle R like this. Look at this. Every time, when only in the case if measures of smaller triangle is given, because another triangle is a bigger one, so definitely that angle will be outside of this triangle PQR. Okay, so let's construct this triangle PQR and LTR. So in this construction of a second question, triangle PQR similar triangle LTR, and in a triangle PQR. Okay, so let's draw that rough figure of the triangle PQR. Okay, so this is the rough figure of a triangle PQR only. Okay, so like this, rough figure is a rough figure. Okay, so PQR. Now in this triangle PQR, PQ is equal to 4.2 centimeter. Okay, now QR is equal to 5.4 centimeter and the PR is equal to 4.5 centimeter. Now as we discuss in that discussion, PQR and LTR both are similar to each other. Now one of them is a smaller and second one is a bigger. Now which triangle is smaller here? That triangle PQR is a smaller, and measures of the triangle PQR is given here. So as we discuss, we have to extend this base to the opposite direction of the common vertex. So first of all we will construct this triangle, and let me show you how to construct that triangle PQR. Okay, so QR is equal to like this. QR is equal to 5.4 centimeter. So we will take that 5.4 centimeter. So this is 5.4 centimeter QR. Okay, so this is Q and this one is R. Now this common vertex should be on the base of the triangle. Okay, so from this Q, how much is the point P? Distance between P and Q 4.2 centimeter. So let's take that 4.2 centimeter in a compass. Okay, so you can take that 4.2 centimeter like this. Okay, 4.2 centimeter. Now hold that compass on a point Q and make one arc like this. Okay, now this is the first arc. Now point P, which is the point here, point P at 4.5 centimeter from this R. So let's take that 4.5 centimeter in a compass. Okay, like this. Okay, this is 4.5 centimeter, and hold this compass on the point R and intersect the first arc. So look at that point of intersection of these two arcs here. Okay, now this is the point P. So let's join these two points Q and R with a P. Okay, this is the first one and this one is the second one. Now as we discuss, in case of such a triangles in which one vertex is a common, we have to extend that base, okay, in opposite direction of the common vertex. So look at this, R is here which is a common. Okay, and then we will extend this base in opposite direction like this. Okay, so this much is enough here. Not only this base but this another side of that triangle R. So we will extend that base and this side like this way. Okay, so here it is. Now from this R, which is a common here, common vertex, we will draw that any angle, acute angle, okay, of 40 degree, 50 degree maximum. Okay, so like this way. Look at this. Okay, need not to measure this angle, this one. You can directly take that ray like this. Now in this figure, one of the ratio is given, that PQ upon LT is equal to, this ratio is given, PQ upon LT is equal to 3 upon 4. Okay, now how much is the maximum number of arc we have to draw here? Which is the maximum number here? 4 is here, so we are going to draw 4 arcs from this point R by taking sufficient distance in a compass. Okay, so I am going to take this. Okay, so the first arc by taking sufficient distance, first arc, look at this first one. Now hold that compass on a first arc, then second arc without changing the distance, keep as it is. Okay, this is the second arc. Now the third one. Okay, and the last one. Okay, so in this way you have to draw that 4 arcs. If this one is R, so write down the name of that point is R1, second point is R2, third point is R3, and fourth one is R4. Now always keep in your mind, as this triangle PQR is a smaller one. Look at this, PQ is the side of triangle PQR, and which is a 3. So every time you have to join the point of a base. Look at this point R, where we draw that ray from here, so which is another point of that base Q, and we have to, if this triangle is a smaller one, you have to join this point, any one of them. Okay, but which point? Now look at this, if this triangle is a smaller, so which is the smaller number here? 3. So we have to join that point Q with the R3 like this. Okay, so this is the R3. Now we have to construct parallel line for this one, Q and R3. For this segment we have to draw that parallel line here. Okay, now how to construct that parallel line? Again with the help of compass we are going to do that. Okay, now hold this compass on a point R3, take a sufficient distance in a compass, make one arc. Look at this arc. Look at this arc, this angle QR3R, this angle is there. Okay, so you have to construct that congruent angle from this R4. For that purpose we are taking sufficient distance, hold this compass on a point R3, make one arc intersecting both sides of that angle. Now don't change the distance, keep as it is, and hold this compass on a point R4 now. Okay, and starting from this side, okay, like this, make one arc. Okay, now which is the first arc? This one. This first arc is here, and 2 points of intersections are here, first one and second one. So we are going to take the distance between that 2 points of intersections like this. Okay, look at here. So this is the point distance between the point of intersection. You can see from here also. Look at this point of intersections, distance between the point of intersections. Okay, now hold this compass on this point of intersection, which is here. Look at this. Okay, intersect this second arc. Okay, so this is the point of intersection, and join this point R with that point. Look at this, this is the point of intersection here, and we have to join this point there. Okay, point R4 with that point of intersection, and extend that line up to the base. That's why we extend this base. Okay, So in this way easily we can construct that parallel line to this one. Now similarly we have to repeat the same procedure here. We have this angle PQR and we have to construct the congruent angle of this PQR from this point. Okay, so again we are going to take the sufficient distance in a compass like this. Okay, hold that compass on a point R, make one arc like this. Okay, intersecting both side of that triangle, angle PQR. Okay, now don't change the distance and hold here. Okay, and again intersect that. Okay, like this. Okay, so this is the second arc. So now take a distance between these 2 points of intersections here like this. Okay, now hold this compass on this first point of intersection, which is a point of intersection here. Okay, so look at here. Okay, here we got that point of intersection. Now join that point of intersection with this point. Okay, so in this way easily you can construct. Now first triangle is a PQR and this PQ is 4.2 centimeter, QR is 5.4 centimeter and this PR is equal to 4.5 centimeter. Now this is the triangle PQR and the another triangle is L. This one is a point T and R. In this way easily you can construct similar triangle PQR and LTR in which this vertex R is a common. Now again keep in your mind, need not to solve anything. If any one vertex is a common, just find out which triangle is a smaller, which triangle is bigger. Okay, and if triangle is a smaller like this PQR is a smaller, so extend this base and this side also. So in this way easily you can complete this construction. So let's move toward the third construction. So this is question number 3 from practice set number 4.1. Again in this question two triangles are given. Triangle RST similar triangle XYZ. Okay, and we have to construct these two triangles. Now in this question not a single vertex is a common in between these two. Okay, so we have to solve that we have to find that corresponding sides and corresponding angles. Okay, so look at in a triangle RST, this RS is equal to 4.5 centimeter, first side of the first triangle. That means we have to find out the corresponding side which is XY. Then angle RST, that means angle S is given which is a 40 degree. We have to find out corresponding angle of second triangle. And side ST, this side ST is given 5.7 centimeter. So we have to find out YZ. Okay, so let's find out that corresponding sides and corresponding angles. As we know that first of all we will draw that rough figure for our convenience. Okay, like this. Okay, so in this triangle RST, this is R, S and T. Okay, this RS is given 4.5 centimeter and ST is given which is 5.7 centimeter. Okay, and angle RST, look at this angle 40 degree. So let's find out the corresponding sides of this triangle RST. Okay, so which two triangles are given? Triangle RST is similar triangle XYZ. Okay, and we know that if two triangles are similar then corresponding sides in a proportion. So let's write down that corresponding sides in a proportion. So RS upon XY is equal to ST upon YZ is equal to RT upon XZ. Okay, these are the corresponding sides of similar triangle, and just write down the reason here. CSST, corresponding sides of similar triangle. So let's put down the values. Okay, so RS is equal to 4.5 centimeter upon XY, we have to find out corresponding side. Okay, then ST is equal to 5.7 centimeter, therefore we have to find out this YZ, and this RT is not given, so keep as it is. RT upon XZ is equal to one of the ratio, that RS upon XY is given, which is the 3 upon 5, like this. Okay, so let's find out that value here by taking first ratio and this one. So 4.5 upon XY is equal to 3 upon 5. Okay, so by making cross multiplication, we can write here like this. Okay, so 3 into XY, so that will be 3 into XY is equal to 4.5 into 5. So XY is equal to 4.5 into 5 upon 3, like this. Okay, so 3 ones are 3, here again 3 ones are 3, 1 remain, so 3 5s are 15. Okay, but that will be a 1.5, so that XY is equal to, so 15 5s are 75, but this is not a 15, 1.5 is this one, so 7.5 centimeter. Okay, here we got that first side of the second triangle, which is 7.5 centimeter. Okay, so let's find out the second side of the second triangle. Okay, so 5.7, which is ST is given 5.7, so we have to find out this YZ. So take that ratio, so 5.7 upon YZ is equal to again 3 upon 5. So again by making cross multiplication, this will be 3YZ is equal to 5.7 into 5. Okay, so transfer this 3 to this side, so YZ is equal to 5.7 into 5 upon 3. Okay, again 3 ones are 3, 3 ones are 3, 2 remain, so it will become 27, so 3 9s are 27. Okay, now here 1.9 into 5, so 19 5s are 95, but this is not a 19. Okay, this is 1.9, so that answer will be YZ is equal to 9.5 centimeter. Okay, so here you got that second side of the second triangle also. Not only this much, okay, but one of the angle is also given. Look at this, angle RST. If angle RST is given, so which is the corresponding angle of this? Yes, corresponding angle of that S is Y. So we can write here angle RST congruent angle XYZ. Okay, and why this is so? We have to write that reason. CAST, corresponding angle of similar triangle. But what? This angle RST is given, which is 40 degree, and both are congruent to each other. So therefore angle XYZ is equal to also 40 degree. Okay, here we got that corresponding sides and corresponding angle of that second triangle. Now we can draw that rough figure here of the second triangle with the help of these measures. Okay, so again rough figure like this. Okay, this is the triangle XYZ. This angle XYZ is equal to 40 degree. xy is equal to 7.5 centimeter and this yz is equal to 9.5 centimeter. So in this way easily you can find the corresponding sides and corresponding angle of the second triangle. So let's construct these two triangles. So first of all we are going to construct this triangle RST. So which is the base? ST is the base and length of that ST is 5.7 centimeter. Okay, so it's very easy. So let's take that 5.7 centimeter. Okay, 5.7 centimeter up to here. Okay, so this is point S and this one is T. This is 5.7 centimeter. Now measure of this angle S is equal to 40 degrees. So with the help of this protractor we can easily measure that angle S, which is 40 degree. Okay, so if we keep this protractor on a point S, we have to start counting from this point T. 10, 20, 30, 40 is here. Okay, so we will mark over here and join that mark with a S. Okay, like this. Now this angle S, that means angle RST is equal to 40 degree. So this point R at a distance 4.5 centimeter from this S. So let's take that 4.5 centimeter in a compass. Okay, so like this 4.5 centimeter, here it is. Okay, look at this 4.5 centimeter. Now hold this compass on a point S. Okay, and make one arc like this. So this is a point R. Okay, and join this point R with the T. Okay, so this is the triangle RST, 4.5 centimeter here. This angle RST is equal to 40 degree and ST is equal to 5.7 centimeter. Okay, so similarly we are going to construct another triangle which is XYZ, and base of that XYZ is 9YZ, which is 9.5 centimeter. So let's take that 9.5 centimeter here. Okay, this is 9.5 centimeter. Now this angle, this is a Y and this one is Z. So 9.5 centimeter. Now this angle Y is equal to 40 degree again. So which is the corresponding angle of angle S. Okay, so let's start counting from which point? Okay, from the Z. Okay, so here it is 10, 20, 30 and 40. So here it is the 40 degree mark over here. So let's join that 40 degree here. Okay, so this is 40 degree angle. Now this X at 7.5 centimeter from this Y. So let's take that 7.5 centimeter in a compass. Okay, 7.5. Here is 7.5 and you can adjust up to the 0, or you can take like this 0 to 7.5. Okay, now hold this compass on point Y and make one arc like this. So this is a point X, vertex X rather, and let's join that vertex X to the Z. So we will get this third side of the triangle XYZ. Okay, okay, here it is. So this is the triangle XYZ. This XY is equal to 7.5 centimeter. This angle XYZ is 40 degree and this base is 9.5 centimeter. So in this way easily we can construct both triangles which are similar to each other. First triangle is RST, this one, and second one is XYZ. How simple is this? So let's move toward the next example. So this is question number 4 from the practice set number 4.1. Again, two similar triangles are given. But look at this. This vertex A is common in between these two triangles. Okay. Now if any vertex is a common, then need not to solve anything. Okay. Now second thing is we have to find out measures of which triangle is given, and this ratio will help us. This AM upon AH is equal to 7 upon 5. Okay. Now this 7 is greater than 5 and this 7 is corresponding with AM, and AM is the side of this AMT. And look at this, in a triangle AMT, that means measures of triangle, bigger triangle rather, are given. So in case of this triangle, need not to extend that base and side of that common angle. Okay, but one thing is keep in your mind, the common vertex should be on a base. Okay, so let's construct these two triangles which are AMT and a triangle AHE. Triangle AMT and a triangle AHE which are similar to each other. Now as we discussed in a question number 2, we have to find out which triangle is smaller and which is the bigger one. Now look at this, ratio is given 7 upon 5. Now 7 is corresponding with AM, and AM is the side of this triangle AMT. Okay, that means this triangle AMT is a bigger one and AHE is a smaller one, and measures of the bigger triangle are given, so need not to extend that base and side of that given angle. So let's construct this triangle AMT. Okay, now for that purpose we can just draw that rough figure of that given triangle. Okay, like this. Okay, as we discussed in a question number 2, this common vertex should be on a base. So this is A, M, and this one is T. Okay, now this AM is equal to 6.3 centimeter and this TAM is equal to 50 degree and this AT is equal to 5.6 centimeter. So let's construct this triangle first of all. Okay, now here we are going to take that AM which is 6.3 centimeter. Okay, so this is the 0 here. You can rotate that pencil over here. So 6.3 like this. Okay, up to here. So this is the segment AM. Okay, 6.3 we will write later on. Now this angle A is equal to 50 degree. TAM is equal to 50 degree. So we will keep this protractor on this point M. Now start counting from the opposite vertex or opposite point. So this is 10, 20, 30, 40 and 50 is here. Okay, so mark over here and let's join that point to the A. Okay, so this is the ray. Now this point T at 5.6 centimeter from this A. So we will take that 5.6 centimeter in a compass. So 0 is here. So hold that compass here and 5.6 centimeter like this. Look at here. 5.6 centimeter. And hold this compass on a point A and make one arc. Okay, so this is the point T. Okay, now join this point T with a M. Okay, so that you will get that triangle AMT. Now as we discussed in a question number 2 also, we have to draw one ray. Okay, So let's draw one ray from this common vertex A like this. Okay, so how much is the maximum number in this ratio? This 7 is the maximum number, so we have to take sufficient distance in a compass like this. Okay, now hold this compass on a point A, make one arc. Look at the first one, this one is the first arc. Now hold this compass on a first arc, second arc is here. Similarly you can construct this one, third. Okay, like this. Now hold again here, this is the fourth, this is the fifth, sixth and seventh one. Look at here. Okay, so this is the seventh arc. So if this one is A, so this will be A1, A2, A3, A4, A5, A6 and A7. Now we have to join this point to any one of these, but which point? As this triangle is a bigger triangle, so we have to join this point M here to the last one, that is A7. So let's join that point M to the A7. Okay, now we have to construct that parallel line from this point M to this line. Okay, so how to construct? Just very similar to the question number 2. We have to keep this compass on A7, take a sufficient distance. Now this is the angle, which one? This angle A7M, this is the angle, and we are going to construct congruent angle from this A5, which is the vertex for that angle. So by taking sufficient distance, we can make one arc like this. Look at this arc. Okay, now don't change the distance, keep as it is now, and hold this compass on a point is A5. Now again make one arc like this. Okay, now take a distance between the 2 points of intersection of the first arc. This is the first one and this one is the second one. So let's take that point of intersection, distance between the 2 points of intersection. So like this. So look at here. So this is the distance between the point of intersection of the first arc, and we are going to keep here on the point of intersection of the second arc like this. Okay, and intersect the second arc. Okay, here we got that second point of intersection. Now look at this one, and let's join this point A5 to that point of intersection like this, and extend up to the base of the first triangle. So this is the parallel line. So similar procedure we are going to repeat here. So keep that compass on a point M like this, take a sufficient distance and make one arc like this. Look at this. This is the one arc. Now don't change the distance, keep this compass on this line here. Okay, and make second arc like this. Now take a distance between 2 points of intersections of the first one. Okay, look at this. Okay, and so hold this compass on this first point of intersection and intersect the second arc like this. Okay, so let's join this point here, okay, to that point of intersection and extend up to the here. Okay, so this is the another parallel line for this one. Now here are the two triangles are ready. So first triangle is AMT and second triangle is AH. Look at this H, which is the smaller triangle, AHE. Okay, so let's write down the measures of that all. Okay, so first triangle is AMT. The measure of that triangle AMT is given. So which side is given? So this side AT is given 5.6 centimeter here. So up to here you can write like this. Okay, this one. Okay, this side is given. Now this side is also given. How much it is? 6.3 centimeter. But that is not AH. AM is there, so we are going to draw like this. Okay, from here to here, like this. Okay, and this angle, which one? TAM is equal to 50 degree, which is the common angle for these both triangles. So in this way easily you can construct triangle AMT and a triangle AHE, in which this vertex A is a common vertex. As this common vertex is there, so need not to solve anything, directly you can construct this one. How simple is this? So this much is enough in this video. Keep watching my channel Maths Equation.